Um, Thank you for being present for this presentation. The title is Impact of Social Transfer on Depressive Symptoms, Evidence from the South African Old Age Pension. Basically, this is just an exercise to check the relationship between income and health in the case of the old age pension in South Africa. So I will just start right away. By the way, it's a joint work with a colleague at Northern University, Dr. Joseph Jeffro. Okay, so by way of introduction, there's always interest in the relationship between income and health, obviously because of the implication it has for poverty and inequality and the health of the poor. And this evidence concerning a gradient of health with income has been documented from as far back as 1851. However, the econometric problem here is that the relationship runs in both directions. By that, I mean that income can affect health and health in turn can affect income. So we have a classic case of reverse causality going on there. So it becomes a bit difficult to make causal argument without breaking that reverse causality. So that's one important part of the study. The other important part is that when we're talking about the relationship between income and health, there's a lot of focus on other health outcome, and there is a lot less focus on health outcome when it comes to mental health. So this paper attempts to fill that gap. So there are two basic reasons why we expect income to vary with the health of an individual. The conventional Grossman health production model implies that if you have more income, you can shift the budget constraint outwards, which means you are increasing your utility, which is measured with health in this case. And another important explanation to that is the psychology literature has shown that stress associated with poverty can predispose individual to mental health, while on the other hand, mental health in itself in turn increases the risk of falling into and remaining in poverty. So there is from the theoretical point of view, there is a relationship between income and health. So for this particular case, we look at the relationship between income and health using the South African old age pension. Because the South African old age pension is an exogenous income, it allows us to break the reverse causality problem that I just talked about. So we are looking at it from how income affects health in such a way that we are not confounded by the relationship coming from the other side. So we measure the exogenous income is the old age income, and mental health is measured by the CES-D 10 variable in the NEETS dataset. I will still talk more about the dataset in a bit. So basically that allows us to make causal argument between the two variables. So a bit of introduction on the old age pension. South African old age pension is a monthly income transfer, and eligibility is based on age and a means test. So age, the threshold is 60 years. So people that are 60 years and above are qualified to apply for the old age pension. In 2017, which is when our data, where our data was sourced from, the old age income is 1,600 for individuals over 60 and 1,620 for individuals over 75 years. This compared favorably with the upper poverty line of 1,138 rands in 2017. So it's actually a substantial amount. So in terms of means test, the beneficiary must not earn more than 78,000 in a year, or if the person is single, or 156,000 if the person is married or has a partner. That is combined income for 156,000. Furthermore, there is a further restriction on the net worth of individuals that can benefit. The net worth should not be should be at most 1.1 million if single and 2.3 million if married. One important thing with our study that we need to bear in mind is that because people can anticipate, because somebody going towards 60 years old can anticipate that he or she will be receiving the old age pension at age 60, it means that there can be an effect on mental health even before the person reaches that age because of that anticipation. So we kind of interpret our estimate here as a lower bound of the estimate because something may have happened to mental health before the person actually clocked 60. So in terms of the sample, our data is sourced from week 5 of the National Income Dynamic Study. That was, the survey was conducted in 2017. And like I said before, we measured depressive symptoms with the 10-item CES-D 10 measure. This measure basically asks questions about how people are feeling and emotional well-being in general on a 4-point scale. So we actually have to code the variable and then before we sum it up and then have the derived variable that we call depressive symptoms. So the questions, certain feelings or behavior occur, the question in the form of asking somebody if certain feeling or behavior occur rarely or none of the time, some of the time, occasionally or moderate amount of time, or all of the time. So we code that those variable accordingly, and the sum of them represent what we are referring to as depressive symptoms there, or depression scores. So the score basically range from 0 to 30. Normally when these instruments are used, they are used in lieu of, so there's often scarcity of professionals who do psychological evaluation, and this screening instrument can indicate if somebody is at risk of depression. So for the CES-D 10 measure, anybody that's scored 10 or above is regarded as being at risk of depression. And this measure has been used in various studies, and they are very correlated with actual validated symptoms of depression conducted by professionals. So in terms of the sample, this point is important. We reckon with treatment on individual level, i.e. the treatment group members are those that reported benefiting from the old age pension. So we did not use the condition of if you are over 60, because that would then mean that we're talking about the intention to treat, because it's not everybody that's over 60 that is actually benefiting from the old age pension. And so that's for the treatment group. For the control group, we look at people who are below 60 years old, actually from 50 years to 60 years, that would otherwise qualify for the grant. In other words, they qualify in terms of their income, they qualify in terms of their net worth. Basically, they qualify in terms of the means test, but they are not benefiting from the grant because they have not met the age threshold requirements. Another important point to note is that it is possible in this setting to have people that are benefiting partially. So imagine somebody who is married, somebody who is 60 years or above, who is married to somebody that is slightly younger, maybe 59, and they are living in the same household. That person, that other person that is below 60 is a partial beneficiary of the grant, because if you assume that the household is sharing resources, it means that person is benefiting from a part of the grant. This kind of individual actually dropped from our sample completely. And I will explain more why, the reason why we do this. It has something to do with the mechanism we think through which the income is affecting depression scores. So all partial beneficiaries are dropped from the sample. Finally, the sample is restricted to those who are between age 50 and 80 years old. That is the biggest sample because like I will explain in just a moment, the method we are using actually as a data-driven method of selecting a subsample where we think that the estimate is credible. So in terms of included covariate, we control for or maybe I shouldn't have put age here. Age is the running variable, but in the fixed effect regression that I will show you towards the end of the presentation, we actually controlled for age too. So we control for marital status, race, schooling, religion. Household income is controlled for automatically by the means test, geolocation, and importantly, negative events that occur in the household. So things like death of a household member, theft or destruction of crop or property, negative events, and all those things. So those that information is available in the needs data, and we control for all those variables. So talking in terms of method, given that there is an age eligibility criteria for the old age pension, it's natural to use regression discontinuity design to estimate the impact. The fundamental assumption is that the probability of receiving old age pension jumps discontinuously at that age. That is, people just below 60 and people just above 60 sort of have the same characteristics, apart from the fact that people above 60 actually qualify to receive the grant. So this introduces a variation in treatment assignments, and this variation is related to potential confounders. If we assume that people just around that threshold have the same characteristics. So that's sort of the assumption that the traditional RD design is based on. And the estimation of it relies on non-parametric identification. So you do a non-parametric regression on either side of the threshold, and you can pick up a difference in your non-parametric regression curve at that threshold. That is one way to go about it. Recently, another method was introduced because often RD designs are being talked about as approximating some kind of random experiment. So Cataneo et al. 2015 actually introduced method that one can use to estimate the effects of under regression discontinuity design, where one is actually using the mechanism that will be used under an actual randomized experiment. So the way the approach works is that one difficulty with using the conventional RD design is that you have a trade-off between the bias of your estimate and the efficiency. So you want to have as many observations as possible to make sure that your standard error is valid. But in order to do that, you have to move away from the threshold. So there's a trade-off there. The further you move away from the threshold, the more observations you have. But the less valid your estimate might actually be in terms of bias, because people that are further away from the threshold on either side may actually have very different characteristics compared to those that are closer to the threshold. So this approach actually deals with that problem in a nice way, because it uses a data-driven method to actually select the window within which the estimation will be done. But the method too has its own shortcoming. The problem is that sometimes when you run that data-driven method, you end up with a window that is so small that the number of observations is just a few, so you don't have a lot of observation to work with, and that can have effect on the standard error of the estimate. So, like I said, the method uses a data-driven randomized based window selection procedure that is based on balance test. So basically, all the other covariates that we intend to control for, the method check for balance between those who are on one side of the threshold and the other side, and choose a window based on the balance statistics. So it only chooses a window for estimation where all the covariates that were included in the analysis are balanced. So in that window, you can assume that you're dealing with a random experiment. Of course, you still have to talk about the problem of unmeasured factor. But because you are using an RDD design, you don't expect that to be a big factor. So inference is basically based on that estimation window. And like I said, in some cases, the window may become very, very small. So a number of concerns that we try to address in the paper, because the assumption is that all the other covariates, there is no jump in them across the threshold. But there are factors that we know that it can change because of that threshold of 60 years. For example, in terms of gender, life expectancy, at least in 2017, between males and females in South Africa are very different. For males, it's 60.4, and for females, it's 67.4. So there's a chance that we may actually have more female on the treatment side of the analysis than on the control side. Employment status is also another source of concern, because it's possible for people to retire around that age, and that's retirement in itself can have effect on mental health apart from what the old age pension is doing. Apart from that, there is a relationship between employment status and depressive symptoms in itself, which has been shown in the literature. So all those concerns come into play in our analysis. Now, because it was difficult for us to find a window around the threshold where gender is actually balanced, probably due to the life expectancy factor I mentioned just now, we actually have to disaggregate the analysis by gender and employment status, just to try to get a more credible estimate that is not affected by those factors. So all the other variables, we're able to find windows where those variables are balanced around the threshold, and we use those the data sets selected by the data-driven method to do our estimation. I've mentioned this earlier. We interpret our estimate as a lower bound of the effect estimate, because there can be an effect of anticipation. People can anticipate that since they are going to be receiving the grant, that can have an effect on their mental health even before they reach the age of qualification. So one other thing that is often done in terms of regression discontinuity is the manipulation of the running variable. And we believe that this is not a strong factor in this analysis. One, the fact that South African has a robust ID system where the age of an individual is shown, and this document will have been produced way before the person reached the age of 60 years. So it's difficult to manipulate age because you have to submit the ID as part of the documentation. And even in the case where it was possible to manipulate age, it's possible this argument was made by Amber, who investigated the effect of old age pension on women autonomy. She argued that even if people misreport their age to SASA, they have no reason to misreport their age to NITS, because NITS is a separate thing. So we're still likely to be capturing the right age. But and similar argument for the network, because it depends on your maybe income statement that you present to SASA that will determine whether you qualify for the grant or not. Again, even if people are misreporting their income to SASA, they have no reason to misreport their income to NITS. So that reduces the risk from that point of view. But despite the fact that we performed the test by McCrary 2008 to show that the running variable is not manipulated. And this is the result of the test. So basically what the test does is that checks the density of the running variable, which is age in this case, and checks whether there is significant difference in the threshold. The implication of that, if there is the significant difference at the threshold, then it may mean that there is manipulation going on at that threshold, and that is the reason why we're picking up the effect we're picking up. But in this case, we find that there is no significant difference in the running variable at the threshold. So we believe that there is no manipulation of the running variable in this case. So before I move on to the result, I just want to talk a little bit about the mechanism, why we think we should pick up an effect or if we pick up an effect, why we think we are picking up that effect. So there is evidence that autonomy is related to less risk of depression. This has been shown in the psychology literature that people exercising personal agency actually protects them from being depressed. And it is the loss of this personal agency or autonomy is one of the risk factors for depression. And when we look at the household income in the treatment and the control group, I'm not showing the full summary statistics because there is no space for it. I'm only showing this one because it's very important to talk about the mechanism. And we'll see that on average, people in the treatment group have lower income than people in the control group, whether you consider the full household income or the household income from labor market or the household income per capita. So it's slightly lower in the treatment group than in the control group. And the mechanism, what we think is happening is related to what the argument of, it is not actually the household income that matters in this case, because this has to do with personal agency. It has a lot to do with the share of income an individual actually controls. The idea is that when the share of income, household income an individual controls goes up, the person tends to exercise more personal agency, because then if you want to do something in a certain way, because you have the power to pay for it, you may be able to decide what will be done. So getting that income is likely to increase the bargaining power of beneficiaries, and that in turn will have that ability to exercise personal agency will have an effect on depression score. We expect that effect to be that increasing your share of income, share of the household income you control should reduce depression score, because then you can allocate resources to things you care about as against things other people in the household care about in terms of bargaining. So here, the share of household income for beneficiaries changed by 22% and 18% for unemployed and employed people. And since the share of income for people that otherwise qualify for the grant but are not benefiting from the grant because they are below the age of 60 has not changed from what it used to be, this difference is what we think is driving the result we are picking up. So before I go to the result, one more thing, I just checked the summary statistics for the depression scores for the treatment and the control group. I disaggregated by gender and then employment status. And one thing you will notice is that in each gender/employment category, the mean score is higher for women, and that is consistent with what we have in the literature. The only exception is for the unemployed men, where the difference is slightly higher for women than for men than for women. So if you compare this figure here, 8.29 to 8.09. Another thing is that the difference between the treatment and the control group is significant in all categories, in all the other categories, like I mentioned. The highest difference we pick up is for unemployed men, which is this row right here. There's a significant difference between the mean depression score between treatment and control group. This is related to an argument that has been made in the literature. There is a relationship between employment status and depressive symptoms, and it seems that the effect is stronger for men. We kind of make the argument in the paper, although we have no definite proof for it. We suggest that perhaps this has something to do with the fact that men are supposed in traditional setting to be the breadwinner. So maybe employment status have a larger effect on their mental well-being than women. But of course, across other categories too, we pick up a significant difference. So because that's not really what we investigated, we didn't pay more attention to that. So going on to the result, like I said, we separated the result into different groups based on employment status and gender. This figure here shows the result for the full sample. This is the popular RD figure that you see in almost every paper that uses RD. And you can see that there is a significant drop in the differential score at the threshold. And this table presents the result for those who are employed. Now, the thing is that because unemployment is generally high in South Africa, the population of those who are employed is very small, which means that the window that we're choosing around the cutoff is even a smaller sample. So we're not using all the observations of people from 50 years to 80 years. The estimation is based on the windows selected by the algorithm. So for all of it, all of the data, we have this estimate, but it's not significant. Optimal window here just gives us the age limit. So this runs from 59.4, those who 59.4 years old to 60.6. So this is a very small window, and we have only 228 observations in that window. So that may explain the reason why we are not, the standard error is large compared to the estimate itself. So when we use employed, when we separate the group and use the employed sample alone, this is the estimate we have here. Again, the sample is very small. Number of treated observation is 99 and control is 170. And then we did the same analysis by gender. For female, we find a significant estimate, even though the sample is still small. And for male, the estimate is still negative, but it's not statistically significant. Initially, when we wrote this paper, we actually excluded this result. But we got a comment where a reviewer said we should actually just present the result and note the limitation of the result. So this is not the table that our main result is based on. Our main result is based on the unemployed sample because we have more observations there. And you can see here, the estimate is consistent, negative, and significant. The reason why I have 4 columns here is that this first one exclude gender. The second one exclude marital status, because in this window we weren't able to find, in this analysis we weren't able to find a window for females where the marital status is balanced across treatment and control group. This row here just gives you the idea of the p-value. So this is the p-value for the covariate that has the minimum p-value of all the covariates we used. So the point here is that the estimate is consistently negative and significant. Because the sample is larger here, we trust this result more. What again? So we notice that the effect is slightly larger for unemployed male compared to unemployed female. Again, perhaps this has something to do with the fact that not being employed has maybe a bigger effect on males relative to females. So we now start to check the robustness of the results. So the first thing we thought of is that it's possible for some people to actually be receiving private pension or UIF. So we exclude them from the sample and did the analysis again. The result is still similar, but the effect is larger. It's still negative and significant. And then because of the relationship between employment status and depression scores, we looked into the wave 4 of the data. This analysis is based on wave 5, and we restrict the sample for those who reported being unemployed in wave 4 and in wave 5. The result still remains the same. It's still negative, about around 1, and statistically significant. So for that robustness check, because each estimation we disaggregate the data, and we have different windows where we estimate the treatment effect. We check the sensitivity of the estimate to the choice of the window. So this analysis is actually suggested by the by Catania 2015. that introduced the method. So on this column here, you have the effect estimate, and here you have the window length. And this analysis, this red portion, just shows you the confidence interval for the treatment effect estimate based on varying window lengths. And what we pick up here is that the effect is negative, is non-positive throughout, at least between the window 1.5 and 3.75. So people that are, their age is 1.5 or 3.75 away from the threshold of 60, the estimate is negative, and the confidence interval of the estimate doesn't cross the 0 point. For the robustness check, we consider the possibility that what we are picking up in this cross-sectional analysis may not be controlling for individual fixed effects. For instance, some individuals might be more disposed to depression, probably because of genetics, or maybe something that happened in the past that affected them that affected their mental health in a negative way. They might be more predisposed to depression. So we use wave 4 and wave 5 of the NITS data set, and we estimate, we use a Poisson fixed effects regression. The argument there is based on the fact that the paper by Zimmerman and Kitten argued that because the questions that we used to derive our depression variable asks how many times an event or a feeling happened. So that variable can actually be modeled as a count variable. So we use Poisson fixed effect here. Even though the estimate is considerably smaller than what we are picking up for the RD design, it's still negative and significant. And here we control for other things we couldn't control for, like in the RD design, we control for province, we control even for age, the running variable, and we still find a negative and significant effect. Lastly, we consider the possibility that the effects might vary with the level of depression score. The idea here is that the effect might be non-linear. People that have higher depression scores may be benefiting more from the grant than people that have relatively moderate level of in terms of their depression scores. And so we use a quantile regression to try to check that. And the result is shown here. As you can see, as we move to the upper part of the depression distribution, the effect is negative and significant. It's larger at the upper part of the distribution. So that means the old age pension actually has more effect on those whose depression score initially are higher. So that is all of the analysis. In conclusion, we find evidence for income health gradients in depressive symptoms. The effect vary by gender and employment status. And it also varies by the initial level of depression score. So those who are more depressed tend to benefit more than those who are less depressed, or those who are more at risk of depression benefit more than those who are less at risk of depression. Lastly, we argue that the exogenous income increases the ability of beneficiaries to exercise personal agency or autonomy, and that is why we think that we are picking up the effect we are picking up. That is all that I have. Thank you very much.